Hey, just wanted to hop in to say that the ideas presented in this video can probably be used in different game engines. I use Unity, so I use all the Unity specific lingo to make the code, but if you look hard enough, you can probably use this in any other engine. Thanks. Let's begin. We as humans just love animations. There's just something about objects beautifully moving left, right, down or up, and scaling themselves in a nice manner that just seems appealing. Although we can't really pin down why we do this doesn't stop animators, YouTubers and game developers from using animations as a means to create appealing media. Because I mean, look at this. Animations are everywhere. From websites to games to the YouTube video you're watching right now. Animations are literally everywhere. The question arises, how are these made? The most universal way of animating things is by using keyframes that each modify a value of a certain object. This goes for literally all animation related stuff in every tool ever. The value that is keyframed could be the position, rotation, or for example the scale of the object. The user has to create a keyframe for each time they want to modify the value, and then the program smoothly transitions between them. The transitioning between keyframes, or more like individual values set by them, is called lerping. If you're making a game, you'll probably end up making tons of animations for many things. An issue arises when you want to procedurally change and animate the values. Animations are usually pre-made assets that just get played, not modified. So what then? The answer to all our issues is lerping. Or more specifically for our Unity use case, Mathf.Lerping. But before we delve further into the concept of lerping, I wanted to tell you guys that my third-person action slasher game Robo Samurai recently got a Steam page, and I'll be really glad if you wish to do. I've been working on it for the past 4 years, and it would help me a ton to boost it up a little bit to reach more people that would find it interesting. That's it. Now back to the lerping. Like I said, Mathf.Lerp is the key to our mystery of procedurally animating values. I've seen countless forum posts about the set function, but for some reason nobody really knows how to use it, and especially how to use it in a controlled and an efficient manner. The function parameters for Mathf.Lerp are simple. A is for the start value, B is for the end value, and T is the time between the two floats you're animating. If you aren't familiar with this function yet, the idea is that simple. Like I previously said, you have two values, and T basically tells how close the value we want is to either of those, like a distance of sorts. The T parameter is obviously clamped between 0 and 1, because you can only distance yourself so much from the two values. I have to note that the value that you get from Mathf.Lerp will also be clamped between A and B. Pretty logical. And that's it for the basics of Mathf.Lerp. There is a lot of different uses for this function, as you can probably imagine, but today's video is strictly about animating values. Therefore, in order to present the powerful nature of the Mathf.Lerp function, we have to use it in a combination with coroutines. I'm going to assume you know the basics of coroutines in Unity. If you don't, check the description for the docs and good tutorials about them. Let's go over some of the most basic yet highly effective code for lerping with coroutines. We first have to declare our coroutine function by typing IEnumerator, and then function name and the parameters we need in order to start animating. Those being the target value to animate to, and the duration that we want the animation to last for. And it would be cool to actually have a value to animate. At the start of the function we declare two variables. We need the start time variable to take note of when we started the animation. We then need a float for storing the initial value of the value we want to animate. Then after that, we need to create a while loop that will keep going until the animation finishes. So just do all that while the time is smaller than start time plus duration. In the while loop, we first want to declare a completion variable that will be calculated on each iteration that gives us the 0 to 1 value of how long we are into the animation. We obviously do this like we calculate any percentage, so time minus start all divided by the animation's duration. Please note that up until now we've been using time, but if you wanted to make an animation that's independent of the scene's timescale, you can just replace every time with time that's unscaled time. It will work the same, but we'll just ignore the currently set timescale. Now back to the while loop, we can finally get to the actual Mathf.Lerp part of the code. All we have to do is set the reference value as the Mathf.Lerp function by providing it the before mentioned start value, the target value, and the completion variable. And after that, don't forget to yield return null, since we want to keep iterating the while loop. The last thing that I would add is set the animated value to the target value after the while loop, just to make sure that we end up with the target value at the end. This setup is almost perfect. In order to use this, you have to declare a coroutine variable that will store the current animation, and just start the coroutine like this. This makes sure that only a single animation can play at the same time, and that we can reset them as many times as we want. You can use this code to animate any value in your code, from UI sliders to FOVs. You can animate anything. So much so that Mathf.Lerp isn't the only thing you can use. Other Lerp-related functions hide in the different Unity classes. The examples being the vector2.lerp, vector3.lerp, and color.lerp. Those are the examples I could find and actually use in my games. You can use each of them to lerp different variable types and animate them with ease. Just replace the Mathf with the type that you want and that's it. The code has been pretty nice so far, but there is one thing I want to add to it and show you guys. One of my favorite things in Unity when it comes to animating is the animation curve variable type. Animation curves define how a value v changes over t. You can change how the curve behaves in any way you want in the Unity inspector. And the best thing is, we can use animation curves in our animation coroutine. All we have to do is declare a public variable for the curve, and then in the lerp function of your choosing, we replace the completion with animation curve.evaluate, and then we add the completion back into the curve function we just made. This way, the otherwise linear straight 0 to 1 completion variable changes based on the curve we provide in the inspector, which allows us to make more appealing animations. Very cool. And yeah, this is the final code. Like said previously, you can use this method to animate any position, any color, any value, as long as you can access and modify it. The animation curves allows us to make the animations just better overall and make the lerps themselves more juicy. Thanks for giving me the time to show you one of my favorite concepts I've learned from game development. If you like what you saw and want to watch more of this kind of stuff, please consider subscribing. Or better yet, wishlist my game Robo Samurai on Steam. All my videos, like this one, are made based on what I've learned on my 4-year journey developing this game, so if you decide to wishlist my game, thank you. This channel motivates me to do the thing I love to do the most, and learn more about game development. Thank you for watching, and I hope to see you in the next one.